Fun science, fun science, fun science, it's a science of fun, yeah.
Today I'd like to tell you some cool things about light! Now, as I'm sure you're aware, the speed of light is 299,792,458 meters per second, which is pretty... The Doppler effect, which is still really interesting, so, don't leave just yet. The Doppler effect is the change that you notice in the frequency of a wave when the source of that wave is moving relative to you. For example, imagine that you're sitting by a canal enjoying the lovely British weather when suddenly... I appear next to you screaming like a lunatic. From your perspective, it's just really, really weird. However, if theoretically I wasn't standing next to you but was running past you at 80 miles an hour, still screaming just as I was before, as I approach you, the pitch of my scream would be higher, and then as I pass and run away from you, the pitch of my scream would drop. Even though from my perspective, I'm screaming at exactly the same pitch as our shift in pitch happens, is because when I'm sitting still and screaming, the sound waves are emitting from my mouth uniformly. But when I start moving, the sound waves in front of me get squished up, and the sound waves behind me get stretched out. And it's this change in the frequency that causes the change in pitch as I pass, and that is what the Doppler effect is. The reason the Doppler effect is important is because it doesn't just apply to sound, but it also applies to light. Bet you didn't see that one coming, because it's not a video about light or anything like that, is it? Oh. So just as when something is moving and emitting sound, you can hear a difference in the pitch of that sound, when something is moving and emitting or reflecting light, you can see a difference in the colour of that light. For example, imagine that we're in exactly the same running canal situation as before, except this time I'm not screaming like a lunatic, and instead of running at 80 miles an hour, I'm running at very, very nearly almost the speed of light. What would you see? Well, you probably wouldn't see anything at all, because, as you'll remember, the speed of light is very, very, very fast, and I'd be gone before you even knew I was there. But let's pretend that you had a magic iPhone app that would let you take pictures of me travelling very nearly at the speed of light. What would you see? Well, when I'm running towards you, the light in front of me gets squished, and the frequency of that light gets shifted to the blue end of the visible light spectrum, and so I appear blue. And then as you see me running away from you, the same thing happens in reverse. The light behind me gets stretched out, shifts to the red end of the spectrum, and then I appear to be slightly red. Now, this change in the frequency of light is something that happens all the time. In fact, it's happening right now as I move forwards and backwards from you, but the change is so negligible that you can't notice it unless something is travelling at very, very nearly the speed of light. But easily the coolest thing that happens when you travel at very, very nearly almost the speed of light is that when you do, time slows down. All clocks, whether man-made or biological, like me, tick slower when you're travelling that fast. So back to our thought experiment where I have the ability to run very nearly at the speed of light. Imagine that I decided to take a couple of minute tour around London travelling that fast. Well, it might have only seemed like a couple of minutes to me, but to you, travelling at normal human speed, it would have been many, many years. And so by the time I returned from my very short run, you would have died of old age. And that, ladies and gentlemen, is light. This is the end